Hello everyone, welcome to my YouTube channel Data Partnership. So today I am going to talk about evapotranspiration anomaly, basically ET anomaly, right? So what is that? This is detecting drought in water stress using MODIS ET. MODIS is global data set where we can map evapotranspiration per year. Evapotranspiration I already mentioned in my previous videos on evapotranspiration. So So basically, what is that? ET anomaly is ET evapotranspiration in dry air minus ET is wet air. Actually, there are many other methods also. This is very simple. If you have, if you don't have any data set available, or so in that case, you can use to get an idea about your study area, right? So it will help you. So what is positive anomaly? Higher ET than normal. If it is normal, if evapotranspiration is normal, uh, then it is positive. More water availability, irrigation, wet conditions are there. Similarly, for negative means if it is lower than normal, then it will be negative. Water says drought, reduced vegetation activity. That is true, right? So this directly shows hydroclimatic stress and groundwater soil moisture influence and other things also. We are not talking about those things right now. So similar to my earlier videos, I have these are my codes. Basically, what we have decided AOI, then we can so like this, and this is how to MODIS data we have to load, and then this is the simple function for yearly data, yearly ET, then wet and we have to define the wet year and dry year, and then we have to anomaly is ET dry dot subtract. That's why I mentioned here that it is ET dry year minus ET wet year, right? And then this is the visualization. That's a simple thing. So and then so I have already done that. So that's why this is the code I have showed you. This is the simply I'm just copy pasted here, and then this is the function we have defined, and this is the modis data we have um, uh, imported here, right? So I told you that you can just type here in the modis, then you can get the data and you can talk about and you can see what I'm talking about. All the you can see, you can read about data set, right? And what are the what are the bands here and what are the properties. So a lot of things you can even, and you can citations also. If you are using those in your reports, then you can cite the from here, right? So so that's why, so this is what whatever I showed you, this copy pasted here, and then this is then run. If you run this, then this pictures will come up, right? This is my study area. I have study area I have defined from here, right? So we have now three layers: ET anomaly, right? This is my ET anomaly. If you click here in the white area, this is the mass, this is the urban area, right? So you can see ET mass. In this area, no evapotranspiration, because you refer my earlier video, then you will realize what I'm talking about. If you green area, if you click here, then you will have dry air 554 and wet, right? If you wet air it's 0 and dry air is 554 and total is like this. If you go here somewhere here, click, then we have ET is wet air is 0, it is somewhere in Rajasthan. You can see here, right? And evapotranspiration is then anomaly is like this, right? So it will change in place to place, right? And you can see here dry air it is like this, right? Yeah. And if you see here wet air it is like this, white, right? So some may say that how, why it is showing this. So basically this is the code you can use, and you can play with this. I am not the code actually programmer, just I'm also learning from different sources. So it can help you how to do the things, right? So interpretation means white areas represent location with very low evapotranspiration, typically urban surfaces, barren land, region with limited vegetation cover. These areas contribute little to water loss through evaporation and plant transpiration because vegetation is less and built up is there. But It all depends on areas, time, and data sets also, because there are many other factors also which we are not using right now, because then you need a separate study or other data sets. But this is roughly a good idea to start from here, right? So, so this is if blue means these are the positive anomaly. This is blue one, right? It means higher ET in dry years, irrigation, groundwater buffering, urban or agriculture water supply is there. And similarly, white means stable ET, little hydrological changes, right? So, so you can basically you can use this for your study, right? So thank you. This is what I wanted to show you. Please subscribe my channel, share it, like it, and help me to grow. To improve these skills. And please play with this code. This is not the end. This is the start, and you can put your thoughts into it. Right? Thank you.